Welcome back. In this part, we explore how your Delphi results can shape future scenarios. Let's start with identifying high and low consensus items. High and low consensus. This analysis shows how much participants agree or disagree on a scenario's impact or likelihood. It's measured using the interquartile range, or IQR, a simple but powerful indicator of consensus. IQR less than or equal to 1, high consensus. Ratings are closely aligned. IQR greater than or equal to 3, low consensus. Strong disagreement or potential controversy. This helps you prioritize scenarios for deeper exploration or scenario planning. And of course, you can adjust these thresholds directly in Delphi.org. Let's look at an example. Telemedicine becomes standard. IQR of 1, showing high consensus and a stable trend with broad expert agreement. Universal basic income. IQR of 3.5, showing low consensus. A controversial or uncertain scenario where opinions differ sharply. All of this is calculated, categorized, and visualized automatically by Delphi.org. Cross-impact analysis. Next, we explore how scenarios relate to one another through cross-impact analysis. This method reveals relationships between scenarios by calculating the correlation, R, between their ratings. High correlation, R greater than or equal to 0.7, scenarios are closely connected. Participants tend to link them conceptually. Moderate correlation, 0.3, less than or equal to R less than 0.7, scenarios are moderately related, sharing some overlap or common themes. Weak correlation, R less than 0.3. Scenarios are seen as independent, rated without influence on each other. These insights show hidden interdependencies between scenarios, helping you understand how one development might reinforce or challenge another. In this example, the cross-impact analysis shows a moderate correlation between Thesis 11 and Thesis 3. No strong correlations are observed, while the remaining relationships are classified as weak correlations. Positive values indicate a positive correlation, and negative values indicate a negative correlation. Again, Delphi.org calculates and visualizes these relationships for you automatically. Fuzzy C-means clustering. Finally, let's look at fuzzy C-means clustering, a more flexible approach to scenario grouping. It clusters scenarios based on similarities in expert ratings, but unlike traditional clustering, it allows partial membership across multiple clusters. This captures overlapping themes and complex relationships in your Delphi results. For example, in projection P1, we see 87.96% membership in Cluster 1, 3.4% in Cluster 2, and 8.64% in Cluster 3. That means this scenario is strongly associated with Cluster 1, but still linked to other themes. These clusters are displayed in an interactive 3D visualization, making it easy to spot connections, overlaps, and strategic patterns at a glance. These clusters can serve as the foundation for your discussion and interpretation of the previously analyzed results. We recommend combining different scenario analysis methods with qualitative data, such as participants' comments. As always, Delphi.org calculates and visualizes all of this automatically. Together, these three methods, consensus analysis, cross-impact, and fuzzy clustering, turn your Delphi results into a rich map of expert perspectives, revealing where opinions converge, diverge, and connect.